Hey, Algebra 2 students, this is Mrs. Wagner. I am doing video 2 for the Algebra 2 lesson from 427 to 510. That's actually our week 3 material, so this is the second video. I'll be covering the rest of week 1. So I just want to say a quick hello. Hi, everybody. I've been reading a lot lately. I'm reading a book about gravity, and I just can't put it down. Yeah, so that's your little joke. We're going to go right back over to our document. So we went through Pythagorean theorem in the first video, and now we're going to go to our trig ratios. So trigonometry comes from the word trigon, which means triangle, and metron, which means measure. There are three basic ratios: sine, cosine, and tangent. So this is just a little cartoon. It is not called the hypotenuse, it's called the hypotenuse, which we learned in our other lesson. So sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So it's one of those things where you just have to memorize them. We're going to give you something called SOHCAHTOA to remember them, but all of that is just a way to remember it. Okay, so triangle ABC, it has three endpoints. It has an endpoint A, it has B, and it has C. So when you take a look at that, you see triangle ABC, the three endpoints are called the vertices. The sides are A, B, and C. So the small little letters here, those are the sides. The big capital letters are the endpoints, or they're also called the vertices. You also call angles with capital letters. So angle A would be used. And you could use three letters for an angle, but this is not geometry, so we're not going to go through that. We know about the legs, which are around that right triangle, and we know our opposite side is hypotenuse. We learned that the other day. Okay, so we imagine that a spray bottle is coming and it is spraying the opposite side. So I tried to do that. I drew a lot of different pictures to try to explain that. So let me just go ahead and go back here. And if you look here, you have this triangle. So you imagine that this is your angle A, and there's a spray bottle that's coming up and it's spraying the side that's opposite. So that's how I was trying to explain to you what it looks like on the picture. So if you take a look at the picture here, this picture right here, you can see that angle A, and the side opposite is the one that the spray bottle is hitting. Now, when you take a look at, let me just get that off there. When you take a look at this side C, that's across from the right angle. I'm not going to do another spray bottle because that would be confusing, but it's the longest side, so that's the hypotenuse. So I've got my opposite, I have my hypotenuse. Now we look at what's left. So whatever's left is called the adjacent. So you first do the squirt bottle to find the opposite, then you look at your longest side, which is your hypotenuse, and then whatever is left is the adjacent. The adjacent is attached to the angle. So if you think about it this way, right, if I go back up here and I switch again, okay, if this is my angle A, which is, where's my pen going? Here, this is my angle A, then this side down here, this side right here, that's my adjacent side right there. This side's the opposite. Oh, I'm trying to get my direction right. It's the opposite. So this side's the opposite, but this side down here is the adjacent side. All right. So I'm going to go back up to the document. Okay, so going back up to the document, it makes more sense when we actually put numbers in. So there is a very fun, you're like, is it really that fun? But it is a very fun song for SOHCAHTOA. So somehow my thing got mixed up. So it's going to go like that. There's a very fun song, SOHCAHTOA. Some kids would ask me to please play it. See if you like it. So I try to put little jokes in there. So there's a little comic joke there. The first thing that I did many years ago when I was a trigonometry student is I wrote SOHCAHTOA down on the side of my page. Every time I got a new paper, I wrote it down. So I'm going to tell you, I'm going to remind you, did you write SOHCAHTOA down? Because that's a very good thing to remember. So remember, I'm going to go over this. So you've got your S for your sine, your O for your opposite over your hypotenuse, C is your cosine, adjacent over hypotenuse, T is your tangent, opposite over adjacent. So that's a good way to remember it. That's SOHCAHTOA. So let me just get it off there. All right, so now we come to some pictures that I kind of drew and put in there. They turned out pretty light, so I think if you got a packet, I'm probably going to have to give them a new packet, because when I print it out, you can't see them at all. But you can see it when you look at them online. So we're going to start with this triangle right here. There's a 5, 12, 13 right triangle. And the first thing we're going to do is we're looking at angle X. So let me just it's not working. Let me see. Okay, it's not really working, but that's okay. So here's my angle X right here. So here's my angle X, and I'm looking for the side that's opposite to it, which is 12. So I'm going to label that my OPP. Say OPP, say you know me. All right, you know I'm silly. And then we look for, so that's 12. So then we look for the hypotenuse. It's real big, so it's all hype, right? It's all big, right? So the hypotenuse, that's mad hype, right? So that's the big side. So that's our 13. So we found our opposite and our hypotenuse. So the only thing that's left is our adjacent. So adjacent's the only one I haven't labeled yet. So now we're ready to see what we have. Sine is opposite over hypotenuse. Well, the opposite was 12. The hypotenuse is 13, so that's 12 over 13. Cosine is adjacent over hypotenuse, so that's 5 over 13. And tangent is opposite over adjacent, so that would be 12 over 5. And that's all we're really learning right now for this. So if I have to do my example 2, I'm going to look at I already have the sine. The sine is 6 over 10 because it's opposite over hypotenuse. So that's 6 over 10. I can reduce that to be 3 over 5. The cosine of f, again, this is my f right here. The cosine is my adjacent, which would be 8. I don't know if it's going to allow me to do anything. It looks like it's not allowing me to type anything right now. Not sure. But that would be 8 over 10. And then I'd have to reduce it. And my tangent is opposite over adjacent, so that would be 6 over 8, and I'd have to reduce it. So it looks like it's allowing me to do stuff now. Good. All right. But I'm going to go down here so I don't waste too much of your time. So I say write the SOHCAHTOA down on each paper. I did number 1 for you. Tangent is opposite over adjacent, so I labeled my opposite, right? And then I found my hypotenuse to be 35, and then my adjacent is whatever was left, so it would be 21 over 28, and then that reduces to be 3 over 4. Now if I take a look at this one, which is number 2, the cosine of C. So here's my C right here. So I first would look at what's opposite to the C. Opposite to C is 30. So 30 would be my opposite side. The big side is my hypotenuse, which is the 34, and the 16 would be my adjacent. So cosine, if I remember SOHCAHTOA, cosine is cosine is adjacent, which is 16, over hypotenuse, which is 34. So you would do 16 over 34, and then you would reduce it. So taking a look at the last couple here, sine of C, I'd have to label and say, here's my C, here's my opposite, and this is my hypotenuse, and this is my adjacent, and label them, kind of like what I did for numbers 1 and numbers 5. I went and I labeled them for you. So go ahead and label it, and then remember what sine is. Sine is opposite over hypotenuse, and then you just put the 2 numbers in and you reduce. Tangent of x. So x is down here, so here's my x. Opposite to x is 32. This is my hypotenuse, that's my longest side. This is my adjacent, this 24. Tangent is opposite over adjacent, and then I reduce it. Cosine of A, well, across from this is my opposite. So 16's opposite, 30 is my adjacent and 34 is my hypotenuse. So cosine would be adjacent, which is 30, over the hypotenuse, which is 34, and then I would reduce it. So if I take a look at number 6, the sine of A, I start here with A, and I look for opposite to A. Opposite to A is this 32, so I need to label that 32. This is my hypotenuse, is 40, and then 24 is my adjacent. So I'm going to let you finish that. So what do I want you to do for your self-assessment? Well, I want you to take the paper, and let me go ahead. I can change my viewpoint here. So I want you to take your paper, and I want you to draw a right triangle. So I'm going to draw a right triangle. Mine does not look that good because I'm drawing it from the side. So I want you to draw a right triangle like that. And then I want you to label the points. So you can call it whatever you want. You can call it ABC, XYZ, whatever you want. But when you do that, you have to put the letters in the corners. So you'd have to put a letter here, and a letter here. Okay? And then after you label it, you'd have to say what the vertices is. So the vertices, if I take a look at, this is upside down. So if I take a look at this, I don't really like the light's in the way, so let's just make that better. So if you take a look at this, the vertices are the endpoints of the triangle. So this is a vertice, this is a vertice, this is a vertice. So let's just take a look at what else it says that it wants from you. Let me just change the point of view again. So I actually tell you what it is. So put small letters and then give the trig ratios. So what are trig ratios? So the trig ratios would be the sine, the cosine, and the tangent. Okay, so if I were to do my example, and I'm going to label it F, I'm going to label it WAG for Wagner, right? So I'm going to label my triangle WAG for Wagner, and let me change the point of view one more time here. And if I do that, I don't really like the light here, so let me just make that better. So if I do WAG for Wagner, and then I go ahead and I try to see what's opposite. So this would be a small w, this would be a small a, and this would be a small g. So then I want to take one of my two angles that aren't right. I don't want to pick one that's right. So I'm going to pick angle W. So I'm going to pick angle W. I'm going to put a little arc there, and I'm going to use my spray bottle, right? And let me make my spray bottle look better. Across from angle W is side W. So that's my opposite. So I'm going to label that as my opposite, right? I don't want you to use the same example as me, though. Make something different. And then across from the right angle, or the largest one, is my HYP, right? That's my HYP, which is a small g. And then this one is my adjacent. So that's what it looks like from my picture. So how would I do my trig functions? Well, I would say the sine of W. All right, let me make this look a little bit better. I would say the sine of angle W would be equal to the opposite over the hypotenuse. All right, so I'd start out with that. The sine of my angle W is equal to the opposite over the hypotenuse. Well, the opposite is a small w, so that would be a small w over my hypotenuse, that's g. Okay, so if those small numbers like W, G, and A, if that confuses you, then put numbers in there. Okay, just put numbers in there. Like if that's really confusing, then I can just put numbers in here. I know 6, 8, and 10 is another right triangle. So I could do 6, 8, and 10. And then instead of having that W, I could put a 6 here, right? Because that's my opposite side. That's less confusing. And then 10. Okay, and you don't have to reduce it if you don't want to. So again, if you're really confused about this, just make up your own triangle, make up your own numbers, because that's less confusing, and then tell me what the different trig functions of one of the angles are.